Okay, so we've learned about how to integrate along the x-axis, but now let's talk about how to find the area between curves by integrating on the y-axis. So this is going to happen like if we look at this picture right here of these graphs, this would be a lot harder to figure out what functions on top and what functions on bottom. We kind of can't figure that out if we're talking about it in terms of the x values. So there is no like actual u of y being a larger y value or v of y being the smaller y value in any of these. So we run into a little bit of an issue because it's not easy to set it up with respect to the x-axis where we're looking at it vertically. But what if we look at it horizontally? So kind of like imagine flipping this over. So that y-axis is what we're going to be doing it on. So if we're looking at it from the y-axis, kind of have that on the bottom, you can see now we have a designated top function of u of y and we have a designated bottom function of v of y. I'm going to just give you a visual of that. So again, this would not be, it's not accurate because the y-axis is not the vertical axis. But if you're looking at it in that kind of terms, you'd have where we'd have this u of y is on top, and then this v of y is on the bottom. So you can see there's a clear now area, one on top and one on bottom. So let's talk about how we would set these up. So in this case, we're going to integrate with respect to y, not with respect to x. So in looking at this, we've got let u and v be continuous and u of y be greater than or equal to v of y for all y on the closed interval from a to b. The area A of the region bounded by the curves x equals u of y and x equals v of y on the closed interval from a to b is the integral from a to b of u of y minus v of y with respect to y, or the area equals the x on top minus the x on bottom with respect to y. So let's actually look at one of these examples. So consider a region depicted in the figure below. Find the area of R by integrating with respect to y. So again, in this situation, it wouldn't be valuable, well, we can do it, but it'd be a lot more tricky to evaluate this, find the area here, if we do it with respect to x. But it's a lot simpler. We could do it, we'd have to separate it into two regions. But we can do it with respect to y, where we clearly have, if we do it this way, horizontally instead, we clearly have this top function of g of x, and then we have this bottom function of f of x. So if I were to set this up, this would be finding that area, and we're going to do it with respect to y. So the y bounds are at 0, and then the other y bound is at 1. So from 0 to 1 of 2 minus, oh, well, first actually we need to solve these for getting these formulas in terms of y. So let's see. So if I've got g of x, let's do this over here. So if I've got g of x equals 2 minus x. So if I want to get this in terms of y, so g of x, let's replace that with a y. So y equals 2 minus x. So solving this for x gives x equals 2, or y minus 2. And actually that would be negative x equals y minus 2. So then distributing that negative through, I'd get x equals 2 minus y. Solving this one with respect to y, so this right now is f of x equals x squared. So I'm going to substitute in y for f of x. So that means the square root of y equals x. And normally it would be plus or minus the square root, but because we're in just this region, we're only dealing with the positive square root. Okay, so now that I have solved both of these functions in terms of y, so now I have this written as a function in terms of y instead of in terms of x, I can substitute those in. So the function that's on top, if I'm writing it in terms of y, is 2 minus y. The function that's on the bottom, if I write this in terms of y, is the square root of y. And then again, I'm finding that derivative with respect to y. Or that integral, not derivative, the integral with respect to y. So doing integration, I'm going to get 2y minus y squared over 2 minus 2/3 y to the 3/2, and I'm evaluating this between 0 and 1. Substituting in 1 gives 2 times 1 minus 1 squared over 2 minus 2/3 times 1 to the 3/2 power. And then substituting in 0 is going to make that whole thing 0. So evaluating this will give me 2 minus 1/2 minus 2/3. So to simplify this out, let's get a common denominator. And that common denominator will be 6. So the 2 needs to be multiplied by 6 over 6. The 1/2 needs to be multiplied by 3 over 3. And the 2/3 need to be multiplied by 2 over 2. So when I do that to get that common denominator, I get 12 over 6 minus 3 over 6 minus 4 over 6, which gives me 5/6 units squared.